Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. Here's step 1, here's step 2, here's step 3, and your challenge is to predict the number of bees in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to express the number of bees in any step at all? That's the challenge. If you'd like to accept it, pause the video and see how far you can get. All right, so today we've got bees, and they seem to be in this sort of, I don't know, it looks like a V pattern to start off with, except the bottom of the V gets really big and kind of blocky. Um, so if I think about this, there's sort of this bottom part, right? And then there's the two arms on either side. And the two arms, there's two arms of 1, and then 2, and then 3. So I'm thinking there'll be two arms of 4 over here. So that part's not too bad. And then this bottom part looks like a square, and it's 1 by 1, and then 2 by 2, and then 3 by 3. So this should be a 4 by 4 square, or 16. So 16 plus 4 more is 20, plus 8 more is 28. So I'm going to predict there are 28 bees in step, wait a minute, I just added this step number. 24 bees, so 16 plus 2 arms of 4, that's going to be 24. 24 bees in step 4. All right, let's take a moment to analyze the numbers. Before we do that, have you got a hunch about what kind of pattern this is? Linear, quadratic, something else? Well, I'm going to make a chart to analyze the numbers, and we'll find out what the numbers tell us. So I've got the step number and then the number of bees. And in the first step, there are 3 bees. And the second, that's 4, 5, 6, 7, 8. And in the third, we've got 9, 10, 11, 12, 13, 14, 15. And then in the fourth one, we're saying 24. So let's take the difference between each step. 8 minus 3 is 5, 15 minus 8 is 7, and 24 minus 15 is 9. So we didn't get a constant here. That means it's not linear. Is that what you thought? Well, let's take the difference of the differences and see if we get a constant there. 7 minus 5 is 2, 9 minus 7 is 2. Aha! So in the second order differences, when you get a constant there, you know it's quadratic. And this 2 tells us that our leading term is going to be x squared. You take this number here, divide it by 2, that gives you the coefficient of your x squared term. So x squared is going to be our leading term. And at this point, I think making an equation with what we've drawn up here on the pattern maybe should be pretty easy to do, right? Because we're seeing a square that's the step number squared, so that's this part, the x squared, and then 2 arms of both of the step number, right? So this is a 2 and this is a 2, and that's the step number. So there's 2 of those. So I could write this as x squared, that gives me the square part, plus 2x, and that should give me the arms, because there's 2 arms of each step number, so 2 times x. Let's just try this out and see if it works. So if I plugged in 1 for x there, I'd get 1 squared plus 2 times 1. That would be 1 plus 2 is 3. So that works out. How about in step 2? 2 squared plus 2 times 2. That's 4 plus 4, that's 8. How about in step 3? That's 3 squared plus 2 times 3. So that's 9 plus 6, that's 15. And this should just relate to what you're seeing visually very well. The x squared is this part, and the 2x are these 2 parts here. All right, so I think we can be confident about this equation. Y equals x squared plus 2x. To calculate the number of bees in step 43, we're just going to plug in 43 for x. So we get y equals 43 squared plus 2 times 43. And let's see, 43 squared is 1849. Got that one memorized by now. And then 2 times 43, that's 86. So that is 1935, I think. So in step 43, I'm predicting 1,935 bees. That's a lot of bees. Well, how did that go for you? Did you get 24 for step 4? Did you mistakenly get 28 like I did at first? Did you come up with this equation? Let me know. Thanks, everybody.